the how you can do it and what is the insights, how you can pick it up. Okay, so let us go further. Okay, let me try to share my screen. So, do my screen is visible?
Yes, sir.
Fine. And I request each and every one people to be interactive. I usually get 2 to 3 responses from this class. I think it was about 22% were 24%, and among the 24%, I usually get a 2 to 3 responses. That's why when I question, okay. So try to be attentive and interactive with me, so it will be more helpful to you people. Okay, fine. So, okay, so this was the exercise. So it's reading the CSV file. So you people were familiar about the reading CSV file. Then something exploratory data analysis basics. So df.head, it gives the first 5 columns. Okay, check the head of the data frame. So it's a simple df.head. So by default, it will give the first 5 rows. So if you want to go for number, you can go it by 10. It will give you the first 10 rows. Okay, so it's upon your wish. Then use .info method to to find out how many entries there are. So we can say that df.info gives a most description about the data frame or data sets. It gives the most it gives a description about the data set. So you can see here that it is saying me that class is equal to like whatever the type of my object is pandas.code.frame.data frame. Okay, and my range indexes. My indexes are starting. There are approximately 14. I think it's 1,48,654 entries, and the indexing is starting from 0 to 148653. Okay, and data columns, there are total 13 columns. Okay, so 13 columns include ID, employee name. In ID there is no none object. Okay, means see among my among 148653 index rows, for ID column, I am having 148654 non null objects. Non null objects means there is no none value is present in that column. Similarly, employee, and you can see the data type. The data type is int 64 bytes. Okay, employee name. Employee name also there is not at all none values, and it is an object type. Okay, similarly, job titles there is no none value. Okay, in base page, in base page there is none values. You can see it here. See, I think it is around something 200 figure. So I think the figure was around 209. I think, yeah, you are having around 209 none values in this base pay columns. You can see it here because see, my ranges is my total number of in the rows is 148653, but in base pay I am only having 1,48,045 non-null objects. Means the rest of the 209 approximately, I think taking an approximately, the rest of 200 to 209 values are non values. Okay, you should make a note of it. So this is how you have to go with getting the insights about the data sets. Okay, so it's not like that you are implementing the technique, okay, you are getting the output. It should not be like that. See, whenever you are applying any method, you should be aware of that method, what I am getting from that method, what it is displaying, what insights it is showing to me. Okay, how I can conclude it. Okay, so you should always be aware of it. Okay, it's not like that you are just applying the code and just you're getting the output. It should not be like that. Okay, so you should be trying to pick up some insights about the data sets. That's the main point of the session. Okay, similarly in overtime pay also you're having four null objects and none values. Similarly in other pay also. So it's everything is a float 64, float 64, float type, data types. So it goes on. So data df.info gives you the best description about your data sets. Everything, number of columns, number of array, how many rows, what are the columns, how many null objects is containing, what is the data type that is presenting in the say certain columns. So you will get the best description using .info method. Okay. Then what is the average base pair? It is very simple. So we will get df dot base pair dot mean. Okay, simple, very simple. Df dot base pay, which is our required column, dot mean. Okay. So what is the highest amount of overtime pay in the data set? So it is also very simple. Df dot overtime pay dot max. It will give you the maximum value. Okay, or else I can do like this also. Let me go for like this. Same, it's what from. Okay, you can use the dot method. Dot, see, it is nothing but it is a method. It is a method of this class. This MEAX is a method of this class. Dot max is already a predefined method in my overtime pay. Sorry, it is a predefined method to my data frame, to my pandas. In my pandas, it is an already predefined way. But this max, whatever the max, see, this max method is like it is a inbuilt. It's an inbuilt in Python. It's an inbuilt method in Python. Okay, so that's the main difference between inbuilt methods and class methods. Okay, so be aware of it. Okay, what are class methods and what are inbuilt methods. So the third question is, what is the job title of Joseph Driscoll? Note, use all caps, capital letters, otherwise you may get answer that doesn't match up. Okay, there is also some other name calls which using lowercase Joseph. So it's a very simple. So df, I'm opening my df, I'm calling my df data frame. Again in the df, I am calling again inner indexing. Okay, inner indexing. Again, I am going and finding out my values. So df of employee name equal to. We are here equating. We are trying to. This is type of call we call it equal ternary comparison. It's a comparison operator. Okay, so this is a comparison operator which compares like two left hand side and right side. Okay, then among this data frame, I'm picking up the job title. Okay, so the job title is Captain Fire Suppression. Okay, I think it is something is belongs to some fire department. Okay, for the name Joseph Driscoll. Okay, how much does Joseph Driscoll makes, including benefits? So okay, so it could can be df of df, same, so the same method of what I have followed here. So instead of your job title, I will go for total pay benefits or total pay benefits. Okay, so total pay benefits dot values of 0, because it returns me an array. It returns me an array of 270324. So to pick out these values, I will index it. Just simple. That's it. Okay, or else you can go for like this also, some like inbuilt method also. You can go for inbuilt method. So you directly get the value without an array. Okay, that's up to you. Okay, which will be the most comfortable to you. You can go with it. See, what is the name of the highest paid person, including pay benefits? So df dot using, see, I'm using here something like different. So you people have done something. I have done something quite different. Okay, so it's simple that df dot log. I'm using location indexing. I am giving the df dot total pay benefits dot idx max, which will return me the maximum value index. Okay, see this argument which that have been highlighted, it will give me the index. It will give me the index value of the maximum value in the total column of the total pay benefits. Is it clear? This tf dot total pay benefits dot idx max, is it clear, guys?
Yes, sir.
Yeah, okay. So this I'm
Sir,
giving the,
why is it IDX, sir? It should be only ID max, no, sir?
it's idx max. It's for indexing max. I want to get the index value.
Okay, okay.
Okay, so because you can, I will show you much better. What it is returning me, it is me returning me 0. Okay, 0 means among my total pay benefits value, the maximum value is lying at 0 index. Okay, in my total pay benefits, you can go up here, you can go up here. Okay, so in this section, in this column, The maximum value is this one, which is at index of 0. Okay, so df dot total pay benefits dot index idx max, it will give me this value 0. Okay, which is the index of the maximum value. Okay, so approach can be different, your approach can be different, my approach can be different. Okay, so it will return me the, yeah, the name is Nancy Hill Ford. Okay, Nancy Hill Ford. So, what is the name of the lowest paid person, including benefits? Do you notice something strange about how much he or she is paid? Okay, so you can see that the name of the lowest paid person is something like Joy Lopez, Lopez, and he is paid something minus 618. Do you people agree this minus 618 is the justified one or the related value? Is you
No, sir.
are you applying something strange? Are you observing anything strange? Hello, guys. Can anyone?
It's a negative value. We don't pay in negative.
And it's you don't pay negative. Any companies they doesn't pay negative. Or still something like Divyanshi. I think someone has made a point about this in the class. I think it's Shreyas. Yeah, Shreyas had said that it means that the deduction exceeded the salary amount. As we can say, there is no base amount for Joy, no salary, as he is an external employee being a concern. So, according to me, suggestion might have caused some loss to the company, so the company is deducted. Of course, this might be something your perception. Okay, Shreyas. So each and every person perception is different. Okay, because the something strange you have observed is that minus negative value. Okay, so what will be the conclusion? How will write my conclusion? So you can look at here. So the value is, I think the value is something misplaced. My observation would be the value is misplaced because the pay should not be negative way. Because the total pay, the pay uh, should not be in negative value, which is not justified one. This is against the rule. We cannot see. Of course, if you have done anything wrong, the fine they will not include your fine in your total pay, because if you have something is done, the fine might be something different factor. Okay, so something there is something misplaced of values because whatever the data sets that you are getting, see when you get any data set from your client, it's not damn sure, it's not the thumb rule that each and every value in your data set well defined. Okay, there is no noise, there is no outliers, there is no misplacing of these values, there is no like something not entering correct values. You will get each and every type of problems in your data sets. It's your work, you should pre-process the data set, you should clean the data set, and then after only you have to go for your model building. Okay, because this something, these values are I call this as outlier. I call this minus 61 minus 618.13 as an outlier because it is not in my range. It is not in my range of, if you try to plot the box clocks plot, you will get this point as an outlier. Okay, which is because it is beyond my range. That's the reason. Okay, so this is how you should have to be predict something or insights. This is we call insighting about the data set. You are concluding something about from the data set. So the value is misplaced because the pay should not be negative value. So it is an outlier. So it is an outlier. Okay, are you people satisfied with my statement?
Yes, sir.
Yeah, fine. Then values is misplaced because, okay, fine. And the strange thing is the total pay benefit should not be negative. Okay, something I have done it. So what was the average mean base pay for all employees per year from 2011 to 2014? Okay, so you some of your people have done with using dot group by method. No problem in that because it is also the best suited one actually. But to give something like something to printing statement, I have done it with like this. Okay, so it will give me something like that. It will take the indexing and it will print out the employees, uh, all employees mean average mean base pay for all employees in the certain years. Okay. So how many unique title jobs there are? So it's a simple method df dot job title dot n unique. N unique means number of unique elements. Okay, the method is simple. So you will get there are 2159 unique jobs. Okay, that much it's a great thing. It's a very huge number. So what are the top five most common jobs? Okay, it's also very simple. Df dot job title dot value counts then dot head. It will give me the first five, top five five most common jobs in this data set. Okay, let us do something. Let us try to predict something from this cell. I am having the transit operator, special nurse, registered nurse, aid, public works, police officer. I think these all are government jobs. I think something it is a government jobs. I think. Let us look for it. I think it's a government jobs only. I think it's a transit operator. Yeah, it's something like a bus operator. I think it's something like. So we can say what will be my suggestion. What would be my the conclusion is that most of the top five jobs, the top five jobs in San Francisco, in SF, let me keep it in San Francisco, it's government organized or government organized. Organized. So this is how you have to work with. Okay. So okay, you should apply the method. After applying the method, what are your picking up? What are your observations? Okay, that's the main theme. That's the main of motivation. Okay, so this is how your motivation should be. Okay, for each and every operations. So the top five jobs in San Francisco are government organized one. Okay, then how many job titles were represented by only one person in 2013? Okay, means a single only one job means there is only in 2013 year. So this job title was represented by only a single person. So in a such a way, how many jobs are there? He's asking. Means in a 2000 in a year of 2013, so there is a chance that only one job is represented by a single person. Okay, so in the same way, how many types of jobs are like that? So again, it is very simple. Series dot just it's how I have done it along. Series df dot here 2013 job title value counts. Then again, among the series, I am taking only the series equal to one. So which is giving me around me 202. There are 202 jobs among 2159 jobs. There are 202 jobs that are only represented by a single person in year of 2013. Okay. So how will be my conclusion? See, guys, this is the main task of a data analyst. Okay, this is the basic thing. Of course, you are having something like visualization techniques also. You have to make presentation. We will deal with it in our coming session. I will deal with you how to make a presentation about your data. Okay. So there are 205 jobs on 2159 jobs that are represented by single person that are represented by single person in year 2013. Okay, this is how would your conclusion would like to be. Okay, the second question is how many people have the word chief in their job title? See, something this word chief is something, I think it is something a higher position might be, because you call chief executive officer, chief financial officer, yeah, which is something I think are top in a company, the top paid jobs. They are chief executive officer, chief financial officer. Okay, something if you are chief engineer or like be chief doctor. So chief engineer, chief doctor means the head. He is the head of the department, like that. So how many people have the word chief in their job title? Okay, so something have defined a function that is called def chief string, or if chief in string dot lower return true, else return false. Okay, then I apply this function using the map method, and whatever the result I'm getting, you can see it here. You can see it here. I'm getting something in binary type, okay, which is something it's not useful for me. Okay, the thing that this method is returning is which is of a binary type. So to make it some integer type, I simply apply the sum method, which will give me the 627. Okay, so among 2159 jobs, we are having 627 jobs that are which are where the chief is included. So if chief is included means he might be the head of the department, or he might be the head of the company. Chief executive officer, chief doctor, chief engineer. Okay, so if see, like this is how you should do predict. Okay, this is how should your observation should be. Okay, is there a correlation between the length of the job title and string and salary? Okay, most of the people I think have confused here itself. This is the I think.
Sir,
Yeah, okay.
why we use string dot lower?
Yeah. Sorry, I will say you actually. See, there is a chance that in my job title there is a chance that the chief could be like this. Okay, C H E CHIEF. Okay, this is the one possibility, and the second possibility might be CHIEF. Okay, so what is the problem is that if something let us take, actually it would not happen. What if any of my job title may contains double chiefs, something like that, CHIEF, or it's not CHIEF. Yeah, it's not chief. Okay, let me say that without the string dot lawyer, let me say that if chief in string, okay, instead of using that dot layer, what it does is that it will only consider the small letter chief only. What are the alphabets? Only this chief only it will consider. It will not consider the capital one, because the machine is not aware the difference between small lettered one and the uppercase. Like it is not familiar with, the machine is not aware with the lowercase one and the uppercase one. Like we have to make aware of it. Okay, so because if I try to write this type of code, okay, if I'm excluding dot layer method, it will not consider this chief string, because the machine thinks that, see, this is different and it is different, because the machine is, as a human beings we are aware of that, because for us human being, see, this both words are same, this both words are same as a human being, but for machine these two words are different for machine, because this is in lowercase and this is in uppercase. So there is, so for certain is that what we want to do is that we will convert it into a lower method. Means if my string is something like chief, capital chief, and if I apply this dot lower method, okay, then my string will be converted. Then my string will be converted to small chief. Okay, so then you will not there is you, because you will exclude some, because there is a chance that you will miss something chief words. Okay, so this is how you have to go with. For capital letters only. Yeah, yeah. Sajiv. Upper is for capital letters and lower is for small letter. Yeah. Lower is for lower small letter. What I'm saying is that. So if you are using the dot lower method, let me show you. Dot lower method. I will show you here. Let me show you here. Would be clear. See, I am taking a string called CHIEF chief. Simply dot LOWER. Just see. See, now this capital one is uppercase is converted to lowercase. Okay. See, that's the advantages. That is the main. You have to use the lower method when you are using Go for strings. Okay. Is it clear? I think who has asked this doubt? Who has raised this point?
Yes, sir.
Sneha. Is it clear, Sneha?
Yes, sir. Sir, so here we use map function. So
Yeah.
through this we call that function.
Yeah. Yeah. We are calling that function. See, this map function will applied on the certain column. You can see here, so Sneha. So this map function, what this map function is this is that it will map my predefined, it will map my user defined function on the selected columns. What is the selected column? The selected column is the job title.
Okay, sir.
Yeah, okay, that's the.
Thank
It's
you,
not
sir.
only map. You can use the dot apply method, dot assign method. Okay, but the syntax might be different. If you go for apply method, you have to go for lambda function sometimes. Okay, that's quite different.
Oh, okay, sir.
So there are 627 unique. Sorry, there are 627 uh, chief the chief titled job titles. Okay, so
Yes, sir.
bonus. Okay. Is there a correlation between length of the job title and string and salary? Something actually this doesn't make any sense for me in my for me point of view. That doesn't make any sense. I think it's something like given you for explanation purpose only. So, do you people satisfied with the statement? Will there be any correlation between the length of the job title string and the salary? Are you people familiar about this correlation technique? Anyone?
Yes, sir.
Uh, Taj, can you say me what is correlation? Like in a simple words, in a simple words.
What is the relation? What relationship can be drawn by two factors?
Yeah, two factors. Either it can be positive relation or negative relation.
Yeah, negative
Yeah,
relation.
yeah, that's true. So that is a correlation. Okay. So correlation is nothing but see, if you are trying to let us conclude like this. See, what does the statement is saying that if the length of the if the length let me make it a markdown statement. See, if the length of the if you increase the size of the job title string, okay? If you increase the size of the job title string, will it reflect any increase or or decrease in my total pay benefits? Is it, yeah, total pay benefits? Total pay benefits. Okay, what does this correlation say? Let me give you, no problem. Let us go for this session today only. Let me give you a better explanation. We go for paint. Where is my paint? Let me show you a paper. Actually, there is a explanation about implementation paper. Where it is? APDD modified APS. See, I am having there is a Python file about it. I will show you. Machine learning models, machine learning codes. It's not here. We go for Java program, machine learning codes, C drive files. Yeah, C drive files. Machine learning experiments. Yeah, machine learning experiments. Hybrid and classification of weights. No? It's not this one. Linear regression. Yeah, this one. See, this is something you can see it here. Until this is the bivariate analysis where we do. See, we are having a data set called here we are having data sets called TV, radio, or newspaper. Like how much budget you are spending in TV advertisement, how much budget you are spending in radio advertisement and in newspaper, like how many increasing, how much the sales are going on. Okay, it is like something regression problem. Okay, like in how much budget you are spending in certain like digital media or certain like media or TV or something, radio, newspaper, how it is affecting your sales. Okay, we can see here, sir, we can see here clearly that, see, my TV, my, if you are going to if you are going to invest, see, the TV and sales are having correlation. You can see it here, something positive correlation. Because see, it is started from zero. If you are going on increasing this value, it is going in this way, in my upper way. Means for each and every value, there is something increasing. There is something increasing after going and each and every point. Okay, what is this positive correlation says that if you are trying to, if I'm having an a y future and x future, let the x future be TV and y future be the sales. If one point, like there be 1 unit increase in my x, it will reflect 1 unit or there something certain percent of increase in my y. So what the statement is that, if any chances of increasing of 1 unit in my x variable, it will reflect my sales variable or my y variable with certain percentage. Okay, but here the effect is in a positive direction. Means, it is in a positive direction. Okay, like this is going from, see, from 0 to, it is going from in upward direction. There might be chances that in negative direction. In negative direction, how it will be started is like that. See, this will be the reverse one. You can see, if you reverse this image, if you reverse the image, it will be a negative correlated one. So it will start from here and it will go and goes and downs, comes to here. We call this as the negative correlated variable. Similarly, we call this as positive correlated variable. Means, in positive correlation, if you are changing 1 unit in TV, there might be 1 unit increasing in sales. If you try to increase from 100 to latest thing, previously you have invested $1,100 in your TV advertisement. Okay, at the time the sales be the about your profit in your sales be, let be about 10.5 or $10.11. Okay, now what I'm doing is that I'm going for $120. So if you're trying to invest $120, then the sales might be go for $12. Profit can be go for $12 or something. It can go for $15. Means 1 unit increasing in x. It is if you are increasing in 1 unit in x, it is going to be increasing in y units also. Similarly, there is a the simultaneous increase in y. We call this as a positive correlation. What is negative correlation is that for 1 unit increasing in my x, there will be decreasing in my y. Okay, so it's a different of positive. Means, if you are going to, what will be my positive correlation is that, if you're going to invest $120,000, it might go from $10 to $5. Okay, this we call as negative correlation. Means the arrow will be upward. Okay, the positive correlation value will be +1 and the negative correlation value will be the -1. And if your value is having no correlation, it will be 0. If your the correlation value is 0, means it is indicating that there is no correlation between your values. So for these columns, so what I have done, just I'm taken a predefined function. Actually, for my job title, I am not aware of the length of this string. Okay, then I have defined a predefined function called length string, return next. Okay, you can use for lambda function also. Instead of using this defined function, you can go for the lambda function also. No problem. So df length of the job string, title map, I have applied the same function. So new column is created. New column is created, length of the job string, something 46, 31, 31, 36, 44. Okay, which is saying that, so there are approximately 46 characters in this string. There are 46 characters. Similarly, there are 31 characters in this string. Okay, what it is indicating. Okay, then I've taken these two columns, df dot total pay benefits dot correlate with df dot length of job of string dot method Pearson. We have Spearman correlation, Pearson correlation, but Pearson is best one. Spearman, because both of them are having their advantages and disadvantages. You can use any one of them. I will go for Pearson. Okay, using this method, I'm getting something -0.0368. So let it be. I will taking my approximate value be 0. Okay, means the correlation. What see how we will write my conclusion. So there is a the correlation value. The correlation value is near to zero, which is of course it is very near to zero, which indicates that there is no correlation. There is no correlation between these two variables. Is it clear, guys? There is no the correlation value is near to zero. It indicates that there is no correlation between these two values. The example I can give in my diagram is, see, either it could be this like, it could be like this. So let us take this be the total pay benefits. Let's this feature be length of my job title string. So if you plot the scatter plot, if you try to scatter plot between two of these features, you will get the figure like this. Okay, which is there is no correlation between them. Where there is no correlation between them. Okay, is it clear? What is, see here it is no correlation. Here there is something positive correlation. Okay, here's something. You can see a heat map. I will show you a heat map. See, this is heat map. Heat maps is showing is that my sales and my TV, see my sales and my TV is having 0.78 correlation, means which is near to 1. Similarly, I am having radio and TV. Radio and TV is having about 0.05, which is near to 0. Near to 0 means which is something you are having no correlation. If you are having something -1, then there is something negative correlation. So okay, how this correlation can be visualized using this. Okay, let us take if you are a data analyst. If you're a data analyst, something data you have got something data set from your client. Okay, then you should in order to, yeah, of course this correlation factor is a main factor. It's one of the major issues in our model building. I will discuss this issue. I will discuss this correlation issue in our coming machine learning models. So there is certain statement that if your future columns are correlated, if there is something, if your future columns, like excluding the label column, if your future columns are correlated, then there might be a possibility that your model can be overfitted or underfitted. There is a statement. There is a statement that was given in famous books like stats learning using application of R, which is Springer's publication. We will go up with the statement. I will show you. Okay, this is what the correlation looks like. Okay, you can visualize. We can visualize it using heat map. Okay, this is how we will use heat map. Heat map is predefined in Seaborn library. Okay. So this is it clear with the exercise? Are you do people have any doubts in that exercise? Is it clear for you?
Yes.
Yes, okay. I'm getting response from only one person. Where are the rest of the people?
Yes, sir. Clear, sir.
It's okay. Two. Fine. Okay, you're keeping one charts. Fine. Go.
Hello.
Yeah, hello. Who is this?
Yes, sir, I'm Renuka.
Okay,
I
fine.
had a little doubt about the benefits column.
Benefit
Um,
column. Okay, go. Let me go for this benefit column.
yeah,
Benefits. Benefits. Okay.
example of benefits column. So it contains NaN values. So should we change those with the mean of that column?
Yeah,
Or
okay. That's a good question. That's a good question. Let us go for an explore. Firstly, let us explore this column. Okay, we can share actually, there is no problem. We can see it. See, I'm in my benefit columns. There are about, I think, yeah, you can go with, yeah, because you can see here, Renuka, in my benefits columns, you are having approximately 1,12,491 non-null objects. Means how many non values we are having? I will give you the best. I will give you the best insights about this. Let me copy it. Control C. Control C. Control V, and let me take this one. Benefits. In benefits column, my total non-null objects are, I'm taking minus, okay, divided by, get it before. There are 24% among 100%. You are having 24% of your columns are non-values object. If this value is something like about 50%, which is above 50%, there might be chances that this percentage can be above 50%. Am I right? Not in this case. In your future cases, there might be chance that this value can be. I can go like this. Something where people were about, I think, not familiar about this decimal points. I will multiply it with 100, which is showing me that. So 24% of your this base pay columns are non-values object. So it is better you to go for with something imputation method, like filling these base values with a mean or median. Okay. I think there is something a pretty quite technique. We will go with the Titanic problem. While we are discussing the Titanic problem, I will tell you how to fill the best justified, globally justified non-values of like base values in your non-values. Okay. In our Titanic example, I will give the best example, like how I have encountered it in my previous classes. Okay. So so the total number of there are 24% of non-value subject. So it is better to go for imputations, Renuka. There is no problem. You can go for, if the values is, what I'm saying is that if the values is below, if the values is above 50%, if the value is above 50%, then then it is better to drop that column. Okay, then it's better to don't include that column in your for your model purpose. Okay, you better to drop it is good to drop that column, and you can consider the rest of the columns, because the non-values are above 50%. How you can go with the mean value? It's not quite well justified one. Okay, if this something, if it is below 50%, okay, you can, if it is below 50%, or if it is below 40% also, you can go for below 40% also, not a such an issue. Okay, so you can go for the imputations method, Renuka. Okay, is it clear, Renuka?
Yes, sir. Yes, sir. Thank you,
Yeah.
sir.
If you want to know what are the imputation methods, I can show you.
Yes, sir.
Yeah. Hello, people. Sorry for inconveniences. I have just left out of the class. Renuka, this will be the future imputation methods you can use for. So if you future engine module, we are having missing data imputation. Okay, if you are going for here, we are having mean median imputer, we are having arbitrary number imputer, end tail imputer, categorical imputer, random sample imputer. You will have the description about this also. You will get the description about it. See, if you're going for mean median imputer, mean median imputer replaces missing data by mean or median value of the variable. It works only with the numerical variables only. Okay, make a note of it. It doesn't work with the string variables. Okay, there is no replacement for your string variables. There might be something cases. Okay, this is the code example. You can get it from. Can anyone say what is this density function is looking like? Are you people are familiar about something like distributions, Gaussian distribution, binomial distribution, uniform distribution, log power distributions, T distributions? Are you people are familiar about these distributions?
Yes, sir.
Yeah,
Yes,
because
yes, sir.
this distribution plays a major role in the data science and machine learning. I will show you some insights that I have done in Iris data set. Something exploratory data analysis that I have done in Iris dataset. There it is. I think it's in desktop upload AI course exercise. Exploratory data exploratory analysis. Yeah, data exploratory data analysis on Iris dataset. See, I have not used any predefined machine learning libraries, but I have classified these flowers. I think you people were familiar about this Iris dataset, which is something like Hello World in machine learning. Iris dataset is something like it is an Hello World in machine learning. So you will have three different types of inputs, feature columns like sepal length, four, I think four, yeah. Sepal length, sepal width, petal length, and petal width. Okay, and you will have three features. One is setosa, versicolor, virginica, which are the like three flowers. You have to classify them. Considering these features, you have to classify them. Okay. Then I have done some exploratory data analysis. This is we call bivariate analysis. This is called pair plot. This is called pair plot. So mainly objective is to see classification of iris dataset using probability density function and CDF cumulative distribution functions. You can see it here. What like I will show you. See what it is saying that if my petal length, if my CDF of any flower which is greater than 5, if my petal length is less than 5, if my petal length is less than 5, then it is classified as setosa. Something condition. I will show you the condition. Here it is the condition objective. From the above figure, we can interpret that if my petal length is lesser than or equal to 2 is a setosa, and petal length is greater than 2 and petal length is less than or equal to 2 is a versicolor. If my petal length is greater than 5 is a virginica. Without using any predefined model, I'm just using exploratory data analysis. I have classified this. See, where it is also saying that I can classify setosa with 100% accurate because of using PDF and CDF. And in case of versicolor, that I can classify them with accuracy 95%. Means my setosa flowers are 100% correctly classified, where my versicolors are 95% correctly classified. Similarly, my virginica, I think also virginica is also about 98% classified. Okay, so this is how you can use exploratory data analysis to in classification also. Okay, similarly, see this is a box plots. You can see this dot. This dot is nothing but it is an outlier. Okay, it tells about the percentile of the data. How much percentile of your data is below 50% of your data, below 75%, below 100% of your data. Okay, box plot suggests that quarters of the data points. Okay, from figure. Okay, so we are also having violent plots also. So it is something it looks similar to the box plot, but something it is gives something distributions. See here, it mainly gives the, see this is the median. You can see this is the mean value and this is the spreadness of my data. Okay, see this is the middle dot black color one is my median value and this is the spreadness of my data. Similarly here also. It will give you the spreadness, it will give you the distributions of your data set. Using violent plots, you can come to know about the distributions of your data plates. Similarly, we are having multivariate probability density function, which is to know the distributions of your functions. Some other functions can be like mathematics for exploratory data analysis. Let me go for applied AI course. Yeah, mathematics for data science and machine learning. Similarly, we are having these all codes are for it's exploratory data analysis techniques only. Whatever this is, mathematics for data science and machine learning. Central limit theorem, which is one of the best one for with the central using this central limit theorem, you can convert something from one distribution to another distribution. Okay, you can verify that whether your distribution is following Gaussian distribution or not. Okay, Gaussian distribution is something, if your data is following Gaussian distribution, let us give you some suggestion that in case in future you have got something data, any data which is following Gaussian distribution, so then there is no need of using any machine learning models. You can using some mathematical techniques, you can classify them. You can give something if else condition to the model, something like if else, if value is in between this range, okay, classify them as 0. If value is in between this range, classify them as 1. So this is the main advantages of mathematics. Mathematics plays a major role in machine learning and data science, okay. And I think this is not a very like a very congested or buttified mathematics. This is very good mathematics, I can say that. Statistics, probability, linear algebra, make a note of it. See, you must be very familiar about this language, like mathematical concepts. Linear algebra. In linear algebra will be very more useful for your neural networks, okay, because where the neurons are in a matrix format. Okay, linear algebra. Go with dot product. What is dot product? What are eigenvalues? Okay, and what is the determination inverse of a matrix. Okay, go with everything. Statistics and probability. In statistics mainly go for with the basics like mean, median. Let me show you something. Okay, I will take something of 5 minutes extra. For something there is where will I do? Actually, the file got deleted. I think the file has just been deleted. Okay, so you people must be familiar about statistics. Statistics is nothing but about mean, median, standard deviation, distributions, or something like data analysis techniques like multivariate analysis, bivariate analysis, univariate analysis techniques. Okay, and probability something like that. You are mainly algorithms like Navi based algorithm or logistic regression. Most of your algorithms they go for probability only, conditional probability. Okay, mainly your Navi based algorithm, it is go for conditional probability techniques. Okay, my suggestion is that make a base of it. Okay, I'm not suggesting you that go and take a book and read. Just take a base take a base look of this technique, these concepts. What are the basic methods others are having in these concepts like statistics and probability or linear algebra. It will be more easier to in this coming session because I will mostly deal with the mathematics part only in machine learning. See, coding part is very easy. When it comes to coding, I think it is coding is nothing like it's a cakewalk. You just import the library, pre-process the data, apply the model. But the main task is that which algorithm is better to pick one. Okay, you have around 50 to you have 100 to 200 algorithms. I think it's not a correct figure. I think you can have above them. You can have 200 to 100 to 200 algorithms, but you are not sure which algorithm have to pick for this data set. Okay, when you will be more sure about it is that when you know the max behind for certain algorithms. Okay, so that's the main my motive is to you people to make aware of mathematics. So in coming sessions we will start with machine learning models. So mainly I will focus on the mathematics only rather than focusing on coding. You can get everything coding, and you can get it from youtube's like in so you can get it from something blogs. Okay, but mathematicals is something you will not get it. Okay, fine people. Is it clear? Is it today's class is clear? Are you fine with my exercise this task?
Yes, sir.
Yes.
Yes,
Okay,
sir.
fine.
Yes, sir.
Yes.
Sure, fine. Thank you very much. So tomorrow we will start with the machine learning overview. Actually, today I have to start with the machine learning overview, but instead of that whole time has been go for it has been gone for our like task explanation only. Nope, not a problem. So we will start with the machine learning overview, artificial intelligence overview, and then after we will deal with some algorithms like linear regression. What is the math behind this linear regression? Okay, is there any something? Is it a black box or it is a white box? Let us go for it. Are artificial neural networks, are these convolutional neural networks, are a black box or a white box? Okay. See, until and unless I say it will be a black box for you. But when I say the techniques for this, be attentive. My main question is that be attentive in this class, okay? Because I mostly focus on the max. It will be more useful for you people to go with the algorithms, okay? That's it, guys. Fine, you can leave, guys. You can leave.
Thank you, sir.
Okay.
Thank you, sir.
Sir, are we going to use OpenCV?
Yeah, I will give a demo on the OpenCV, how to use OpenCV and how to use OpenCV to extract some counter. Like example, in case of mask detection, face recognition,
Right,
how
right,
these counters, basically your face will have some counters. How we can extract these counters. I will see you OpenCV. See, I will mainly discuss about OpenCV, NLP, natural language pre-processing, artificial neural networks, okay, deep
right,
learning,
sir.
CNN, okay, which are the main their main topics for this deep learning module, okay. There is
Right,
no
sir.
find out.
And sir, what was the explanation for that negative salary of that employee?
The negative salary is that it is an outlier, Shreyas. It is an outlier.
Okay,
Okay, so it is an outlier because you can see here that the value is something which is beyond that value.
right, beyond the expected value or
We are
permitted
beyond
value.
expected value. So that's why it
Right.
is an outlier. Okay.
Okay, so that's the fault in the data set.
That's how you have to define it. Example, if you are going as a data analyst, if this data set has given to you, see, you
Mm-hmm.
must pick up that point. You must highlight that point in your presentation. It will be something more grateful for you. Okay,
Okay,
company
okay.
will accept you. Okay.
Okay, so it is the outlier in the CSV file or our code?
In our that pay total pay benefits, I think it's a total pay benefits or benefits.
Right, right.
In only in that only special only that columns. In that column only it is the outlier. Okay,
Okay,
which
okay.
is beyond the distribution of the data.
Right.
Okay,
Okay, fine, sir.
fine. Okay, no problem.
Thank you, sir.
Okay.